Hi everyone. Okay, so after our fire drill experiencer in class today, we're going to go through the very bottom of page 9, all of page 10, and the examples on the top of page 11 in the notes. That's what all the other sections got through today. So I just want to make sure that you guys are on the same page. You shouldn't be penalized or rushed tomorrow just because of the fire drill today. So anyway, all you need to do is have your notes nearby and make sure you're filling in your packet and annotating as needed. You can, of course, pause this video, restart it, play it quicker, whatever you need to do to get all the information. Okay, so where we left off, we had just finished mentioning that ionic compounds are neutral overall. And the reason they are neutral overall is because they have equal amounts of positive and negative charge. So when we start writing our formulas, we'll see that inevitably, the total amount of positive charge from the cation is equal to the total amount of negative charge from the anion. Also, we saw earlier in class today that there are 6 groups on the periodic table, what we will call the main group elements. So that would be group 1, 2, 13, 15, 16, and 17 that have set charges. So because those charges are predictable, that's going to help us when we start to write our formulas. So, moving to our next page here. Our next slide says when we're writing ionic formulas, the first thing we want to note is that ionic compounds typically involve a metal cation and a non-metal anion. So generally, if you're trying to decide if an element is a metal or a non-metal, you have something from the left side of the periodic table like a metal and something from the right side like a non-metal. You can also have polyatomic ions involved, but typically we're looking at a metal and some kind of non-metal. Okay, and once again, we see that that net charge is 0. We also know that sometimes our transition metals get involved in ionic compounds. So where are the transition metals? As we mentioned, remember the transition metals are the elements in groups 3 through 12, which you can just say 3 through 12, or you can say 3b through 12b if that's more to your liking. But those are the same. And the deal with those is that they can have more than one charge. So if they can have multiple different charges, we'll need to show that charge using our Roman numerals. Now, you don't need to worry about this example down there at the bottom yet. We're going to save that for tomorrow. So for now, you can just sort of leave that aside. Here's where our main piece of today's lesson is. So how do we actually write a chemical formula for an ionic compound? We're going to use what we'll call the crossover rule. I usually call it the crisscross method, but they mean the same thing. The idea is if we follow this pattern of crisscrossing our ion charges, what we're going to end up doing is we're going to essentially inadvertently make sure that our charge does indeed balance out to 0. This will work with both our monatomic ions, so elements of single element atoms that have become ions. It will also work for polyatomic ions. Okay, the one thing we'll see is we will need parentheses around polyatomic ions sometimes, but we'll come back to that in a minute. So let's check out an example. Now for you guys, this is already filled in, so let me pause, let me get rid of that, and I'll show you how it works in action since you're not seeing this live in class today. Okay, so again, sorry, I know you already saw the answer there, but we want to make sure that you see where this is actually coming from. So what we do anytime we write an ionic formula, so let's say we're writing the formula for sodium sulfide. The first thing you would do is you would look on the periodic table and find sodium. Sodium is in group 1, and we had mentioned that everything in group 1 will have a +1 charge. So we would write our ion. You then would find sulfur. Now, how did I know it was sulfur? Because sulfur sounds like sulfide. So we find the element sulfur on the periodic table, see it's in group 16, and everything in group 16 had a -2 charge. So I'm going to write my ions like that. It does not matter if you write +1 or 1+, they mean the same thing. Same for -2 versus 2-. But here's where our crisscross comes in. So we write our ions first. We then are going to take our ion charges, crisscross them, and make them subscripts on the other element. Now a few notes here. First, you will never write a 1 as a subscript. Yes, it can be a charge, but we are not going to write that as a subscript. Okay. Also, if you can reduce the charges, you should. So, keeping those two things in mind. Oh, and one final one. You drop the charge once it's a subscript. Okay, so those are the 3 quick notes there. So that means our resulting formula for this one would be Na, but after our 2 drop down there, Na2, and then S, and technically we had a 1 dropping down, but as we mentioned, a 1 will never be a subscript. So this is our final answer, Na2S. So those are the steps. Write the ions first, crisscross, and then write your remaining formula. Okay, so you see your answers here for these questions. I would like you to try these on your own first. So please take a moment. Don't be tempted to look at the answers. Pause the video. For all of these examples, write the ions underneath these first, and then check your final answer for each of these formulas. A few to note here. For your final one, your work should look like this. Magnesium oxide, those were your ions. When you crisscross them, here's an example of where you can reduce. 2 and 2 are going to cross out to 1 and 1, and that's why our final formula would be just MgO. Okay? So, if you haven't already, pause, and please try all of these example problems on your own. Okay, now that you have checked your answers to all of these, the next page, we're doing the same exact thing. However, these examples involve polyatomic ions. So once again, before I switch to the next slide, you see 4 different examples on the top of page 11 in your notes. I want you to take the time to write the ions underneath all of those particular names for the ions. Then take some time and crisscross your answers. As far as parentheses go, use your gut about when you think you need them. The rule is you need parentheses around a polyatomic ion anytime the subscript crossing down to it, so the charge essentially crossing down to it, is 2 or higher. Okay? So you guys take some time, try the examples on the top of page 11, and then pause your video. Okay, and here are your answers for those final 4 examples, okay? Just a few so we can see where we got these from. So aluminum, the ion would be this. The sulfate ion, you should have found that on your list of polyatomic ions. And notice when these cross, I would have Al2, and then here's an example of where we need parentheses. Again, the rule for parentheses is you need parentheses around a polyatomic ion anytime this number crossing down is 2 or higher. So a 3 definitely qualifies for parentheses there. Also, then it would look like 43, and that's a little bit weird. Where people normally miss the parentheses is in this example, okay? Because if I wrote my ions for this one, magnesium would be Mg with a +2 charge, hydroxide is OH with a -1. So what people normally don't realize here is that when I cross this 2 down, even though there's not already a subscript here, that's not the point. I'm trying to say that I need 2 of this whole ion to balance out with 1 of these magnesium ions. So the only way to make that 2 count for both the O and the H essentially is if we have the parentheses, so that could distribute. Okay? So again, maybe jot down the rule. Parentheses around a polyatomic ion anytime the charge crossing down to it is 2 or greater. Okay? For the next one, acetate, just a heads up, this can be written that way. You'll also see it written like this. Your textbook likes this way. This is the way that I've always seen as well. So there are a couple different ways to write that. And then your final one we have here. Okay? So I apologize for the, convoluted nature of this video and the fact that you guys didn't get to see this in person. That being said, we'll do plenty of practice with this before the unit's out, so you can of course ask me if you have additional questions. But you do not have a homework assignment yet. Your only homework assignment was to fill in the notes, study your elements for the quiz Thursday, and then get to work memorizing those 30 polyatomic ions. Thank you for watching, and I will see you tomorrow.